Welcome back, Math for Teachers to students. We're looking and diving into lesson 24. We're continuing to talk about proportional reasoning, and this is part 2. As you've done in the past with your video slides, make sure that you hit pause, read your goals. Are you finding math vocabulary? I immediately see 3 or 4 that you should be writing down and making sure that you're comfortable with by the end of this video. Key terms: scaling up and down, cross multiplication, unit rate, and scale factor. So these are all different strategies to solve missing value proportion problems. Right? Scaling up and down, you can see up here. Proportion, equivalent ratios, which we talked about in the previous lesson. We're scaling up by multiplying, and we're scaling down by division. Cross multiplication, we've also talked about this in the past. Unit rate and scale factor. Okay. How you're going to prepare and what will we do in this lesson? Again, it's helpful to hit pause. Some students need extra time. We read with our eyes. Some children prefer to and need to read out loud. You'll see children in your class moving their mouth. Maybe not speaking out loud, but moving their mouth, right? So it's good to read your audience. If you have a slide like this up on the smartboard, then take time to turn around. You've already read this, okay? Take time to turn around, and once you see eyes kind of wandering, or again, if we're reading silently with our lips and our mouth, then when you see that go silent, you know it's time to move forward. Again, I'm choosing to put the resources up front, but you need to think about where the value of videos and other website resources may be most valuable when you're teaching a lesson. Maybe that you're using in-class manipulatives, right? So where you interject these resources, these plus materials, will be up to you as a classroom teacher. Let's take a look. Okay, this website is education.com. I will tell you that it is free. You can see at the top, try premium, but you just need to generate an email and a password. It is free. You can see that I chose to use my .edu email, which is strongly suggested. Whatever your workplace email, keep those things separate, right? So anything that you're using for work, I suggest you use your work email, and then personal is personal. Okay, so this is education.com, and you can see at the top there's a lot of options between worksheets and games, lesson plans, activities, workbooks, exercises, songs, and stories. And then when we look at the breadcrumb here, the search here was the whole library. We went into games. We're looking at 3rd grade, and we know that we're talking about fractions. Okay, so part of this website is that you can play in the classroom. You could share the link for a child or a family to play at home, or you can click assign this game and it will connect to whatever school tool, electronic tool that you're using, like Schoology. Okay, so let's take a look. Reading the description, always previewing anything you're going to use with your children. You're going to read the information, and you can see that this scales up. This scaffolds if you want it to. And then the subject matter, math, fractions, fraction models, fractions as part of a set. So it's covering a lot of different skill sets.
Rolly is craving your famous pancakes. Help him feed his hunger by whipping some up on the griddle. Flip the number of pancakes that matches the fraction on Rolly's order. Ring the bell when the order is ready to go.
Okay, so for this one, it's asking us, I love that your mouse moves the spatula, flip 2/6 of the total pancakes. Yes, 2/6. But we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So think about that mental math. Got it? How many pancakes are we going to flip? 2, 6. So some of your children are going to flip 2, right? And let's ding the bell and see what happens. No, it just gives you a duh-duh. So there's no verbal that says try again, okay? But it flips them back over for you, okay? So 2, 6. 1, 2, 3, 4. Ding. So the happy ding, the high-pitched ding, okay? Here's another one. Flip 1/8 of the total pancakes. But there are 16 pancakes, right? So if there's 16, 8 goes into 16 twice. If we're going to flip 1/8, and we're doing the math, 8 into 16 goes 2. 1 times 2 is 2. Ding. Okay. It takes you this one takes you through 4 or 5 problems, and then it gives you a congratulatory at the end with a big stack of pancakes. Remember to consider what you like about an interactive game or a website, and think about how you might implement this in your classroom without technology. Okay? Without it. So thinking about manipulatives if you were going to do similar activities in the classroom. Good. Okay, so proportional problems. We've looked at how pictures can help students solve and understand problems involving proportional reasoning. Now we're going to start investigating student solution strategies to solve problems that do not involve pictures. So no discrete model, area model, line model, right? We're moving away from pictures onto the paper. So it's important for teachers to be able to analyze students' work in order to understand their thinking, right? We've been doing this all semester. That part's not new. You've been doing that in some of your teaching models as well in the classroom. So we'll be using proportional reasoning lessons as a site to give you extensive experience in analyzing student work and making sense of it. Since it's an important skill, you'll also be assessed on the ability at the end of the unit, right? That's your exit ticket. Story problem here is, on a map, 1/3 inch represents 10 miles. If 2 cities are 2.5 inches apart on the map, what is the actual distance between them? Okay, so take about 10 minutes. You're going to hit pause, okay? If you need to, write it down, the story problem, okay? Think about how you would clearly explain how each of the children in your workbook figure this problem out. Decide whether their strategy is mathematically valid or not. So you want to use your workbook, lesson 24, and the first student is Daisy. That helps, okay? So you're going to hit pause. Hit pause, take your pencil to your workbook or another piece of paper, and work through each of the children that you have and see how they're explaining it and is it mathematically valid or not. Okay, hitting pause. Great, welcome back. Let's look at how Daisy solved the problem. And is her strategy mathematically valid? Okay, so Daisy preserved all of the multiplicative relationships between inches and miles by getting equivalent ratios. The highlighted ratio is called a unit ratio because it is the per 1 ratio. So Daisy said 1/3 inch equals 10 miles. That also means that 1 inch equals 30 miles. 1/2 inch equals 15, and 2 inches equals 60. So all of these various components that she put together, these equations, tells her that 2.5 inches equals 75 miles. And yes, this is valid. Thinking about how Casey did this, right? Casey set up a proportion and solved for the unknown using cross multiplication. This strategy is usually the only strategy that's taught in most of the United States classrooms on how to solve proportional problems, but you're learning different ways, which is great. Okay. So 1/3 of 10 equals 2.5 over x. So 1/3 of x, 1/3 x equals 25. So x equals 75 miles. Beginning to look a lot like algebra. Okay. Where we're finding that unknown quantity. Okay, Eugene also found the unit rate. 1/3 represents 10 miles. 1 inch represents 30. So he did some mental math. Not really, but he jumped, right? Whereas before, Daisy really detailed it out, right? Eugene just jumped and says, okay, 1 inch represents 30 miles, and I need to find out how much 2.5 inches are. Then he jumped down. 2.5 times 30 equals 75. This is also correct. Sam solved it a different way. So hit pause. Sometimes it's helpful to reread up here before you read the strategy that Sam used. So hit pause. Make sure you're understanding this as well. So we've seen different ways to solve proportional problems other than just cross multiplication algorithms. Okay. So again, next 10 minutes, you can continue to work using your workbook. Okay. Think about how each child is solving the problem. Okay. And then you can continue with the following slides. So this video is going to conclude, but the rest of the slides, which there are 9, are going to walk you through the different solutions that the children came up with.